Today we're going to be learning how to find derivatives. So problem number 1, we're finding the derivative in respect to x of x squared. So first what you want to do is you're going to bring the 2 down as shown in the second step, and then you're going to subtract 1 from the exponent. So then you're left with 2x to the 2 minus 1 power, which is then 2x to the first, and this is just 2x. And then on the second one, we have x cubed plus 2x squared plus x plus 30, and we're trying to find the derivative in respect to x. So then we bring down the 3, subtract 1 from the exponent, bring down 2, subtract 1 from the exponent, bring down 1, subtract 1 from the exponent. And since 30 is a constant, the derivative of a constant is always 0. So given that, we have 3x squared plus 4x plus 1. On this one, we're going to have to use the quotient rule, which is low d high minus high d low all over low squared. And d just stands for the derivative of like the high, and then derivative of the low. So on this one, we have x plus 2 divided by x minus 3, and we're trying to find the derivative in respect of x. So then we do the low, which is x minus 3. The derivative of the top function is 1 minus the x plus 2, which is the high part, and then x minus 3, which is the derivative is just 1, and then low squared, and this x minus 3 is on the bottom, so it's x minus 3 squared. That's how you solve for that. Then we have this one, which we also use the quotient rule. Hold on. X squared plus 30 all over x cubed plus 20. So then low x times the derivative of the high, which is just 2x, minus high derivative of the low, which is 3x squared all over x cubed plus 20 squared. Oh, and keep in mind, I'm not simplifying these. You guys can do it yourself. I'm kind of feeling lazy. I don't really feel like simplifying it. But if you want to, you can. You can always simplify. But I'd recommend just leaving it in this form, because otherwise, like, if you simplify, there's gonna be like room for error, which is really bad on like a test or quiz. The next one we're gonna do is we're gonna use the product rule, which is over here, f prime of x times g of x plus f of x times g prime of x. So x of 2 we're going to call f of x, and then x cubed plus 2 is g of x, and we're taking derivative in respect of x. So x plus 2 derivative is just 1, and then x cubed plus 2 is still the same, plus x plus 2, which is f of x, and then the derivative of the g of x, which is x cubed plus 2, is just 3x squared, and that's how we solved it. Then we have number 6. So 2x squared plus 3, which is just 2x, and then g of x is the same, 30x squared minus 2x minus 10, plus x squared plus 3, which is f of x. Then g prime is 60x plus 2. And remember, 10 is a constant, so we just put it as 0. And keep in mind, guys, like you can simplify this if you want, but I chose not to. So that's why everything's like in parentheses. And then here we have the chain rule, which hold on, I have it right here. It's f prime of g of x times g prime of x. So then we have x plus 2 cubed. So this is, I'm going to treat this similarly to the power rule. So I'm going to bring down the exponent, which is just 3. Then you're left with 3 times x plus 2, and then you subtract 1 from the exponent, which is just 1. And then the derivative of the inside is just 1. So your 3 times x plus 2 squared times 1. On this one, you kind of have to know like the derivative of sine is cosine, derivative of cosine is negative sine. So you take the derivative of sine, which is cosine, so then cosine 3x plus 1. Then you take the derivative inside, which is just 3. And number 9, we have cosine 3x squared plus 5. We're taking derivative in respect of x. So derivative of cosine is negative sine. And derivative of 3x squared plus 5 is just 6x. Number 10, we have sine squared of 20x. And on the second step I wrote down, that's another way of like writing it. So you bring down 2. So it's 2 sine 20x to the first power times cosine of 20x times 20. I went through this kind of fast. If you have any questions, leave comments below, and yeah, I'll make another video for you guys. Yeah, so see you then. Bye.